Hello, welcome back to our Obedient School channel. Today we are going to see matrix and its uses of matrix and types of matrices. Mainly this chapter is used for the 10th class to intermediate level. Okay, now we will see what is matrix. Matrix Matrix is a set of numbers arranged in rows and columns so as to form a rectangular array. A matrix is a set of numbers which are arranged in rows and columns to form a rectangular array. The numbers within the array are called elements or entries of the matrix. Matrices have wide applications in engineering, physics, economics, and statistics, as well as in various branches of mathematics. Matrices are used in the engineering, okay, physics, economics, and statistics, as well as in various branches of mathematics. Now, the elements. What are elements? The numbers or characters inside the matrix are called elements. Understood? For example, this is A matrix, first row, second row, and first column, second column, third column, fourth column. This is two rows and four columns. Okay. Inside the matrix, these are the numbers. These numbers are called elements. Okay. Now we see what is the order of the matrix. What is order of matrix? The order of matrix is given in the form of number of rows by number of columns. A matrix is represented as like this. Okay, Mn, where P is the matrix and M is the number of rows and N is the number of columns. In this above matrix, how many rows? 2 rows and 4 columns. Hence, this matrix is called 2 by 4 matrix. Understood? Then we'll see types of matrices. First one, we see row matrix. What is row matrix? In the row matrix, we see only one row and n number of columns. Only one row. In this example, you can see only one row in this matrix. That's why it is called as a row matrix. See, this is minus 1 by 2 and under root of 523. In this matrix, only one row and two columns. Hence, it is called a row matrix. And next matrix is column matrix. Same way like row matrix. In the row matrix, we can see only one row. Same like row matrix. In the column matrix, we see only one column, but n number of rows. For example, see in this example, you can see first row, second row, third row, and fourth row. There are 4 rows, but column is only one. Now next, square matrix. In the square matrix, number of rows is equal to number of columns. A square matrix has the number of columns equal to the number of rows. A matrix in which the number of rows is equal to the number of columns is said to be a square matrix. In this example, you can see 3 rows and 3 columns. Next, rectangular matrix. A matrix is said to be a rectangular when the rows are not equal to columns. For example, see how many rows? 1, 2, 3, 4. 4 rows in this matrix and column 1, 2, 3. So this is the rectangular matrix where M is not equal to N. Next, diagonal matrix. Diagonal matrix is also a square matrix, is said to be a diagonal if all its non-diagonal elements are 0. Non-diagonal element should be 0, and at the same time it should be a square matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. See, in this below example, you can understand very easily what is diagonal matrix. See, there are three examples. In this is a row and column matrix. Why? Because in this you can see only one element. This is 2 by 2 matrix. Non-diagonal elements. This is a diagonal, and what are non-diagonal? This 0 and this 0. So all the non-diagonal elements are 0. In this 3 by 3 matrix, you see a diagonal here, and diagonal consists of a numbers, and other non-diagonal elements are 0. This, and this. Okay, understood? Diagonal matrix is a square matrix, and a square matrix is said to be a diagonal when if all non-diagonal elements are 0. Okay, now scalar matrix. A scalar matrix is said to be a scalar if its diagonal elements are equal. See, in this diagonal you can see all the diagonal elements are equal. In this first one, -1 and -1. Here in this, all three, and the rest non-diagonal element should be 0. A diagonal matrix is said to be a scalar matrix when its diagonal elements are equal to same or equal or same. Okay. So scalar matrix, diagonal matrix, and square matrix. All these three are square matrix only. A square matrix is said to be a diagonal when non-diagonal elements are 0, and a diagonal element is said to be a scalar when these diagonal elements are equal. Understood? Next, 0 or null matrix. A matrix is said to be 0 matrix or null matrix if all elements are 0. Okay, in the 0 or null matrix, all the elements will be equal to 0. We denote 0 matrix by O. For example, you see, in the first one, only one element, that is also 0. In the second one, all 4 elements are 0. In the third one, all the 9 elements are 0. Hence, this is called as a null matrix or 0 matrix. Next, unit or identity matrix. In the unit matrix, as all the elements 0 and each diagonal elements are non-zero, it is called a identity matrix, and it is denoted by I. If a square matrix has all elements 0 and each diagonal elements are non-zero, it is called a identity matrix. See, in this, non-diagonal elements are 0 and diagonal elements should be equal to 1. Okay, understood? Moving to next one. Upper triangular matrix. A square matrix in which all the elements below the diagonal are 0 is known as the upper triangular matrix. Let's see example for your more understanding. First of all, you read the definition again. A upper triangle matrix is a square matrix in which all the elements below the diagonal, from where below the diagonal are 0, is known as the upper triangular matrix. See, if you see, this is the diagonal. So below the diagonal, all non-diagonal elements should be equal to 0. That's why this is called upper triangular. Upper triangular, there will be a non-zero element. Okay. Similar way, we have lower triangular matrix. So upper, opposite of upper is lower. So In upper triangular, all the lower non-diagonal elements will be 0. In the lower triangular, all the upper non-diagonal elements will be 0. That means this, and this. Okay. See, we see the definition. Lower triangular matrix. A square matrix in which all the elements above the diagonal are 0 is known as a lower triangular matrix. Okay. For example, you see this is a diagonal we are getting starting from here. So above the diagonal, all the non-diagonal elements will be equal to 0. Understood? Okay, let's move to the next one. Singular matrix. A singular matrix is a square matrix if its determinant is equal to 0. What is determinant? AD minus BC equal to 0. If AD minus BC equal to 0, then it is called as a singular matrix. Let me show one example for more understanding. See, this is a matrix A is equal to 3, 6, 2, 4. In this is A and this is D, this is B and this is C. Is a singular matrix because 3 into 4 minus 6 into 2, AD minus BC. Det A is equal to AD minus BC. So 3 into 4 minus 6 into 2. 12 minus 12 is equal to 0. Understood? So in this video you have learned what is matrix and where it is used, what is element, what is order and types of matrices. Okay, what is first one? What is first one? Yes, row matrix, column matrix. Understood? Next, yes, unit matrix or null matrix, identity matrix, null matrix, diagonal, scalar. Very good. Upper triangle, lower triangle, singular. Okay, square, rectangular. Okay, can you recall once? Types of matrices: row, column, square, rectangular, diagonal matrix, scalar matrix. Very good. Null matrix, unit or identity matrix, upper triangular matrix, lower triangular matrix, singular matrix. Okay. Thank you all. We'll see in the next lesson with the operations of matrix, that is addition, subtraction and multiplication of matrices. Until then, keep watching Obedient School channel and do subscribe, like and share the videos. Thank you.